SwayamPrabha. Digital India. Educated India.
Hello everyone. So, we will continue with air filtration. So, here we will start with HEPA filtration system. We can see in this diagram, this is the particulate matters coming. First it is actually the coarse particle are entering, and which is coarse particles are arrested by the pre-filters. Okay, the polluted air is coming. So, pre-filter, then here we have HEPA filter, which is relatively higher filtration efficiency, and then we use the ultraviolet light UVC, which actually kills the bacteria and all that. So, UVC we know that we have discussed earlier, it is short wave and which kills the germ. It captures particles 99.9, almost 100% particles, more than 3.3 micron size. Air velocity is 0.45 meter per second typical, and it is used for clean room and hospital. For hospital air cleaning, we use HEPA filter, which is actually high efficiency particulate air, that filtration we are talking about here, and it is constructed with fine fibrous membrane. So, fine fibrous medium we are using to have very high filtration efficiency, but here we need help of a pre-filter, because pre-filter will restrict the larger particles and reduce the load on the HEPA filter. So, filtration efficiency in textile, so air filtration efficiency. So, this is the equation, here it is a filtration efficiency, we have already discussed earlier also. So, particle concentration in inlet, particle concentration in outlet, it shows the percentage of particles removed by the filter. So, it is influenced by fabric density and fiber arrangement. So, if we change the fabric density or fiber arrangement, we can control the efficiency. Now, another way we can increase the filtration efficiency by using the activated carbon. Activated carbon is impregnated on the fabric surface. So, the surface area of activated carbon is, you can see it is a very high surface area. Per gram it is typically 800 to 1500 square meter. So, very high surface area, it absorbs the volatile organic compound. So, that is the, that is why we use the activated carbon, and which actually the odor, the in the maybe in the air or even water. So, to absorb the odor or volatile organic compound, it actually it is used. So, if you see the Langmuir adsorption isotherm, so this is the relationship where Q is the amount of adsorbent absorbed, that is the amount of adsorbent adsorbed on the surface. Q max is the maximum adsorption capacity. So, K is the constant adsorption constant, C is the concentration of adsorbed in the concentration of the adsorbent in the solution or fluid, so it is described monolayer adsorption of molecules on the surface, and it is used in the respirator or industrial filtration. And next is the antimicrobial air filtration. We can either treat the fiber by antimicrobial agent. So, silver nanoparticles are used, it releases the silver ion. Copper nanoparticles are used, which it generates a reactive oxygen species, and presence of silver nanoparticle actually reduces the microbial concentration on the filter, and it will enhance its life, improves filter's lifetime. Next is the industrial baghouse filter. What is baghouse filter? When we have very large volume of contaminants and volume of air and high air velocity, which is generated in the industrial setup like in cement plant or maybe power plant, there large volume of particulate matters generated, and we cannot simply throw it to the environment. We cannot, there is a restriction, we have to arrest all these particles, and industrial baghouse will be sometime it is much bigger than actual industrial activity. Now, if you see here the particulate matters are coming and the particles are actually arrested on the surface of the bag, and clean air is moving through this and which is going out, and the particles which are arrested on the surface, they get deposited and collected at the bottom. This is the basic principle of industrial baghouse, used in typically in cement and steel industries, where large amount of pollutant particles are generated. Filtration velocity is 1 to 2 meter per minute. You can see the velocity is relatively high. Gas flow rate is, you can see that 1000 to 50,000 cubic meter per hour, very high gas flow rate, and particle emission it removes, because it the particle should not be thrown to the air, and as the these particles actually here the speed is very high. So, in that case there will be some small particles will come will be exhausted, but that is basically its quantity is small. So, that type of that is the we have to calculate the filtration efficiency. And you can see here here with the time in this type of bag filtration, the particles are deposited on the surface and gradually the pores are blocked with the time. So, we have to either change the filter, which is economically not viable. So, for that what we have to give either mechanical shaking that mechanical shaking is done by the pulse jet. Some suddenly it will be shaking is there and the particles will drop from the surface. At the same time reverse air flow is there. So, air from the other side comes and due to reverse air flow the particles captured on the surface will be dislodged and will be dropped and segregated. Now, the high temperature filtration is also very much required where hot air is generated, particularly in the environment industrial environment. So, there we have to use some specialized fiber, aramid fibers are used. So, normally polypropylene is used or polyester or nylon, they are used for normal industry bag house, but high temperature filtration, for that we need to use high temperature resistant fiber, aramid fibers are used. Glass fibers also is used which withstand more than 300 degree Celsius. So, industrial exhaust filter where high temperature exhaust is there, for those application we use the high that is this type of fiber, aramid glass fibers are used. High thermal resistance, HVAC textile filtration, heating, ventilation and air conditioning textile filtration. So, for those what we use the spun bonded. Typically air flow is 2 to 5 meter per second, removes dust, any dust more than 1 micron. So, improves indoor air quality, spun bonded melt blown we can use. So, melt blown is for narrow filtration and spun bonded is basically used for mechanical support. So, it is used for building and hospitals. And in situ nanoparticle formation, that principle is used for enhancing the filtration efficiency. So, photocatalytic textile membranes are used, titanium dioxide photocatalysis is basically this is the process of photocatalysis. So, TiO2 it generates reactive oxygen species, it degrades organic pollutants by this process, provides self cleaning filtration. So, that whatever the organic species are actually deposited on the filter surface, that degrades. Okay. So, the reactive oxygen by reactive oxygen which is generated and which degrades the organic pollutants. So, then graphene based textile filters are used where the graphene is impregnated, graphene is generated. So, you can see graphene oxide is a single atomic layered material derived from the chemical oxidation of graphite. So, graphene oxide is actually deposited and characterized by high oxygen concentration. and it is a hydrophilic in nature that enables the aqueous dispersion. So, here the treatment you can see by reducing the in the fabric stage. So, first it is coated with the fabric, graphene oxide is coated on the fabric in the first stage, then it is reduced and we get the reduced graphene based fabric. And another is reduced in dispersion stage. Graphene oxide is reduced in the dispersed stage. So, here it is a dispersed stage, then reduction. Okay. Here at this stage reduction is carried out, and after reduction this is the solution, and then the fabric is it is coated on the fabric. So, two ways we can do. So, surface area is 2630 square meter per gram, strong absorption of organic pollutant. So, after treating this fabric will actually organic pollutants will be absorbed on the surface. So, where organic pollutants are there. So, advanced filtration system in those application we can use this technique, graphene based textile filter, and it is a high electrical conductivity. So, where the chances of other electrical shock and something is there. So, there this type of application where high electric conductivity is required, there we can use this graphene based textile material, textile filters. Now, we can modify the surface of textile fiber for improving the filtration efficiency. Just you can see what are the different ways of modification. We can coat the fiber, we can use the nanotechnology to modify the fiber surface, biotreatment we can use, hydrophobicity we can incorporate, even adsorption we can improve, functionalization we can do, plasma treatment or chemical treatment. So, we can modify by all this way. So, depending on our requirement. So, plasma treatment introduce polar functional groove. So, this is, and this will improve the characteristics depending on our requirement, improve the surface energy and weightability. So, by plasma treatment we can improve the surface energy and it is weightability is increased, enhance adsorption of pollutant and catalytic activities. So, by plasma treatment we can enhance the adsorption of pollutants, and plasma power typically 10 to 100 watt for textile treatment. So, this is the power we use, and sol gel coating technology is also used for filtration. So, forms metal oxide coating, so TiO2, SiO2, that type of coating is used on the fiber, which helps in improving the characteristics like for so hydrolysis reaction for the antimicrobial treatment we can use. So, hydrolysis reaction, this is the hydrolysis reaction. So, produce thin porous coating improving the filtration activity. So, this we can use, enhance the chemical resistance of textile material. So, by sol gel technique, so we can enhance the chemical resistance. There are smart textile filtration systems are there. So, here we can introduce the sensor which will monitor the pollutants, presence of pollutants. So, that within the filters we can use some sensors and type of pollutants present in the air or even in the water, that will sense. So, electronic sensors are there and it will detect the concentration of gas, concentration of particle, okay, or gas pollutants. So, what is the concentration? Even the sensor in the this filter fabric will actually sense, it will detect the concentration, accordingly it will react. So, connected to the IoT based environmental monitoring system. So, it will it is connected, that it will then it will detect. So, the system where the PM 2.5 is detected and it is connected with the IoT device, and if we know the PM 2.5% level or PM 10% level, PM 10. So, PM 2.5, if we know through the IoT device, then it can adapt the filtration performance. And nanotechnology is used for filtration. So, nanoparticle size is 1 to 100 nanometer, that is actually textile fiber is impregnated and it is deposited on the fiber surface. It increases the specific surface area and catalytic activity of the fiber if it is nanoparticle is deposited, or we can generate fiber within the fiber nanoparticles or nanorods are impregnated. So, that this technology we have used for water filtration, and that in the next course we will discuss. And this is used in antimicrobial or photocatalytic textiles that enhance the absorption of pollutants. So, from the air or from water, it will enhance the pollutant adsorption. Functional coatings are also used to enhance the filtration efficiency or some other functionalities. So, nano or microfiber mesh is there, this is the nano or microfiber mesh, and here functionalization layer, this functionalization layer, and then it is a antimicrobial layer. So, super hydrophobic treatment is given here by using the nano or microfiber mesh. So, water will not come, it is becoming, it will not penetrate. Then functionalized layer, which actually depending on the requirement we can use this layer, and at the end it is a microbial layer. So, antimicrobial treatment is given or coating is given, so that it will give some specific function. So, hydrophobic coating improves the oil water separation. So, we can use this hydrophobic coating. So, this hydrophobic coating is used here. Then antimicrobial coating reduces the biofouling membrane, reduce by. So, here it will give the antimicrobial activity. and catalytic coating enables photodegradation of organic pollutants. So, we can use different types of functional coating depending on our requirement. And coating thickness is typically 10 to 100 nanometer. Now, let us try to see the air filters used in the plants. So, this is the in the like cement plant or steel plant, we use this type of filter. So, baghouse filter captures fly ash particulate emissions like cement dust particle or fly ash in power plant. So, that baghouse filters are used. Filtration efficiency, it is more than 99% filtration efficiency is there, used in coal fire power station. So, coal fire power station is basically in those applications where large quantity of particles come. So, in this powerhouse power plant, we use this type of filter. And it reduce the particulate emission below 50 milligram per cubic meter. So, which is typically acceptable environmentally. So, but it should be 0 typically, but you cannot make it 0. So, that is within the acceptable limit. Then let us see the structure of automotive filters, automotive air filtration. Now, here the dry air is coming from the environment. Now, dry air with the pollutants, different types of pollutants are there. Now, here the super fine fibers are used, super hydrophobic treatment is given and antimicrobial treatment is given. Now, and we are finally getting the clean filtered air in the cabin, automotive cabin. So, outside there may be different level of filtration pollution, but here the PM 2.5 or PM 10 is reduced. So, the engine air filter captures dust particle more than 10 micron. So, engine air filter is there. So, more than 10 micron it will capture. So, it will improve the engine efficiency and lifespan. So, engine air filter is there. So, textile filter media, the airflow is high airflow we can have. So, 300 cubic meter per hour. So, that type of air velocity, and it reduces the emission of harmful gases. So, that we can control the harmful gases. Industrial gas filtration. So, different types of gases comes there, and in the toxic industry, basically the toxic industrial gases and particles, and textile filter that removes the toxic gases. By this toxic gas can be absorbed by the fiber, which is treated with different types of functional treatment. So, filtration efficiency typically 90 to 99% used in chemical industry, where toxic gases generation is there, and pharmaceutical industries. This type of industries, we gas filtration is used, maintain safe working environment. Now, coming to the biodegradable textiles, where we use natural fibers, typically natural fibers are used to improve the sustainability. The natural fibers that degrades through microbial action, those are used. Environmental waste is reduced, that is carbon footprint is reduced to a greater extent, and reduce the waste and carbon generation. An example, the cellulose or chitosan fibers are used. So, they are coming from the natural source, they get degraded easily. So, suitable for eco-friendly filtration system. So, if we want eco-friendly degradable filtration system, we use the natural fibers. And we can create the circular economy. So, normally what happened in the air filter, in the filter we try to throw it to the environment and create the environmental pollution. So, if we use the circular economy approach in textile filtration, that can actually reduce the carbon footprint to a greater extent. So, we can try to reuse and recycle the filter medium. So, it will reduce the cost also. So, we should try to reduce the carbon footprint by recycling. So, we can do recycling if we use say thermoplastic fiber, that we can again clean and wash, and then we can again melt, or we can produce the fiber by mechanical recycling, which will reduce the industrial waste, we can extend the life cycle of textile filter. So, we can reuse this filter media, or we can use some cleaning mechanism, and for say some bacterial filtration, in that case we can sanitize first, then we can try to reuse. So, that approach we should circular economy approach we should use, we should adopt here to reduce the cost and reduce the environmental impact. So, to promote the sustainable manufacturing in the filter. So, we should use, if not 100%, but some proportion of the recycled fiber we should use to produce any filter fabric. So, that approach we can use. So, if we see the life cycle assessment here, so we should first evaluate the environmental impact from production to disposal. So, you can see here, this is a manufacturing process, okay, and your transportation, then whatever we do the construction or you do the manufacturing of the say here, if we see the example of the pleated filter or mask. So, we are constructing the mask here, then we are using some that is the here we can use, and then we are trying to recycle. So, that approach we should use, and we can use what is the energy consumption during the production process. So, if we know the energy consumption here, then we can calculate the for recycling how much energy we are reducing, energy consumption or emission we are reducing, carbon emission, how much carbon emission we are reducing, that we can measure, and it supports sustainable product development. So, that we should encourage the sustainable product development, and life cycle analysis methodology we can adopt, and now the performance testing of textile filters, how the performance is tested. So, filtration efficiency testing is using the standard aerosol test. So, we normally do not take the natural air, because we do because in the air, if we try to take, then the particle concentration or pattern of the particle, different types of combinations are different at different places, and even in the same place at different time throughout the year, it keeps on changing. So, that standardization is not possible. So, standard aerosol is used for testing, and pressure drop is measured, and durability is tested. Basically, durability, typically bursting strength, tensile, tear, all these tests are performed, and through repeated filtration cycle. So, that repeated apart from this, repeated filtration cycles are also used. That means, how long this filter can be used. Standard, there are different types of standard protocols are there, ASTM, ISO standards are there. Now, as I have mentioned that only single layer filtration is not enough, we need to use hybrid filtration. So, hybrid filtration to have multiple activity, like the filter we are using for PM 2.5 or dust, that type of particle filtration, that filter may not be able to absorb the gas. So, that activated carbon is impregnated on the this textile material. If we use, then it will absorb the gases or volatile organic compounds. So, different layers are used. So, hybrid filters are used for multiple activities. So, combined adsorption, catalysis and membrane filtration, that we combine to have multiple effect. Like membrane is typically used for water filtration, liquid filtration, and improve removal of complex pollutants. So, what is complex pollutant? Where the nature of the pollutants are mixed in. One is particles, normal particle, dust particles are here, but along with the dust particles, suppose gas is coming. So, gaseous particle. So, in that get complex pollutants, in those cases we cannot filter everything using a single filter layer. For that we need hybrid filtration. Industrial wastewater treatment, we can use this even for some gaseous pollutant like toxic gases, we can use this type of hybrid filter, and it enhances the long term filtration efficiency because of multiple activity. So, it enhances the filtration efficiency for long term. Also, we can create the self cleaning textile filters, which repels and kills the microbe particles. So, if we treat the textile filter with the antimicrobial finishing, so it will repel and kill the microbe. So, it will have this characteristics and also respond to high heat and fire. So, that fire protective treatment can also be given in the filtration for high heat transmission. So, photocatalytic coating degrade the contamination. So, we can use the photocatalytic coating which can degrade the contamination at the surface level, and then we can it will be cleaned, and it which reduces the membrane fouling, it improves the operational lifespans of filters. So, operational life you can increase. So, often use titanium dioxide, zinc oxide nanoparticles are used. So, self cleaning membranes are used here. We can also use the smart environmental monitoring on the textile. So, that I have already mentioned. So, you can use which actually we can it can detect the humidity and temperature, that monitor we can incorporate, detect the pollutant and environmental condition. It provides environmental condition means humidity and temperature it can detect, provide real time data on air quality. So, if it detects the pollutant, type of pollutant, quantity of pollutant, it detects the temperature, humidity through IoT control, okay. Then real time data can be generated, and this integrated sensors connected to IoT system. So, sensors embedded within the textile filter, one sensor is embedded which actually detect the all these parameters which has been discussed. Pollutant it will detect in real time, connected to digital monitoring system. You can know that what is the pollutant concentration. Use in small smart cities, that we can use this type of filter. So, now try to understand what are the different types of emerging research trends in the area of filtration. Research is going on in the area of nanofiber composite membrane for filtration, particularly the water filtration and also air filtration. Integration of graphene or carbon nanotube material. So, that our in-house research on impregnation of or integration of carbon nanotube on the textile to improve the functionality, that I will discuss later in the next course, part 2 of this course for water filtration. During water filtration, that we will discuss. So, advanced multifunctional textiles. So, there are multifunctional textiles in that area, different types of research studies are going on, and now the study is directed towards the sustainability, reuse. Okay. So, life cycle assessment are doing, and to reduce the carbon footprint. So, this is the area which the majority of research should go through towards all these directions. multifunctional activities that in the filter fabric that we can use. So, let us try to briefly understand the economic aspects of filtration in textile. So, you can see here textile fibers are cheaper than ceramic membrane. So, that is why textile fibers are used, and also textile fibers are flexible. You can change the shape, you can fold it, you can pleat it. So, that due to its flexibility textile fibers are used. Textile filters are widely used, particularly for air filtration. And another is the production is scalable. You can have large scale production in the industry. So, textile fibers are that is why it is a large scale, very high rate of production. So, it becomes cheaper, and also it is a lower energy consumption due to high permeability. So, pressure drop as compared to other type of filter, the pressure drop here is much lower than other type of membranes for air filtration. So, which actually generates the results the lower energy consumption. So, textile, that is why textile filter market is growing throughout the world, in world market. So, the environmental benefits for with the textile filters, it actually it reduces the air pollution level. So, using the textile filter we can reduce the air pollution level, we can actually arrest the pollutants at the source, like the main source is say automobile. So, automobile exhaust, if it is filtered out before it is actually exhausted to the air, so that will reduce the air pollution. And for cement industry, power plant, that we can reduce the air pollution. It protects the ecosystem and human health. So, as we know that we are trying to protect ourselves through the filter. So, human health protection is there, and it supports the sustainable industrial development. So, we can actually reuse the textile filter, and it enables the clean production technology. We can reduce the power consumption by adopting the life cycle analysis. Now, let us discuss the summary what we have already discussed. So, summary is that the textile material provides effective pollution control technologies, and nanofiber membranes significantly improve the filtration efficiency by providing the higher surface. We can enhance the functionality by functional coating, and which will remove enhance the pollutant removal performance, and sustainable material will dominate the future research. So, future research will be dominated by sustainable research. So, these are the major takeaways from our present discussion. So, why should we go for textiles, not the other material for air filtration? So, textile based filtration plays crucial role in environmental protection. Advanced nanotechnology improves the filtration performance. We can integrate the smart system in the textile by for monitoring the air pollution control, because textile is flexible, anything can be embedded depending on our requirement, but this is not possible for other material because it is flexible, and here we can use nanotechnology. So, nanotechnology to improve the filtration, that we have already discussed. And in textile filters, another advantage is that we can use different types of fiber combination, different fiber diameter, we can different types of fabric structure, we can change the thickness easily. So, to control the air filtration efficiency and to reduce the pressure drop, and textile is the easiest solution, and through which the in large number of researches are going on for developing the sustainable filtration technology, because textile material can be reused. Some other material cannot be, normally it is difficult to reuse, but textile can easily be reused to the system, and that will this is the positive points of textile material for filtration. And we will stop here and we will start we will continue with the air filtration. Till then, thank you.